Hello, everyone. Thank you for joining us today. This is Jim May, Marketing Manager at Index Corporation. And today we are going to be focusing on properly producing medical parts in this webinar. We are joined today live by Mike Huggett, our National Sales Director. Mike has 4 years in at Index now and a history of over 30 years in the industry. We are also joined from Germany at our parent company Index Werke by Marc Lehmann, our Global Key Accounts Manager for Medical. Marc has been with Index 2 years now. He has 15 years in medical sales and 9 years as a CNC machine builder. So he really brings a unique perspective and source of expertise to this conversation. Today, we're going to be taking some quick dives into starting out common materials that are found in medical applications. And then we're going to be moving on to 4 specific applications, looking both at the parts, the challenges they present, and then the machine solutions that Index has provided that our customers are using to produce those parts today. So we have hip cups, tulip heads, bone screws, and bone nails will be the 4 products we focus on today. Now, because Marc is joining us from Germany, we had done some tests from a technical standpoint and discovered it would be best to pre-record portions of this webinar. So we're going to go ahead and start a video right now while we have everyone live on the phone, and then we'll break away from this in a bit to take questions from both Marc or for both Marc and Mike. If you have any questions at any point during the presentation, you can just go ahead and submit those in the question box on the dashboard on your screen. Thank you.
Hello, I would like to speak today about the medical material which we have in a normal way in a medical area. Cobalt chrome. Doctors use cobalt chrome for hip, shoulder, knee implants, as well for crowns and bridges in the dental field. The cobalt chrome is biocompatible to the human body for temporary and permanent implants. Other advantages are the high wear resistance by low flexibility. The surface of the implants must be perfect, otherwise the debris can cause bone destruction or some inflammation. For the machining, it gives some challenges. Sometimes the chips sticks to tools. For this reason, lubrication is required. An advantage is that with carbide tools, small radius cutting edge is possible. We recommend that the tool must be coated. An articulation surface requires really a perfect surface regarding the healing process. Titanium will be used for screws, plates, implants, as well for dental implants and abutments. Titanium have also a very good biocompatibility to the human body. Advantages is a high wear resistance by low flexibility. The surface of the implant to be perfect, otherwise also here exists debris. For the machining, it gives some challenges. Sometimes the chips sticks to the tool. For this reason, lubrication is required. The titanium chips are extremely flammable. For carbide tool, ultra-fine grain is required. Tool must be coated for roughing and uncoated for finishing. Stainless steel products will be used usually for cutting and uncutting instrument like pliers, tweezers, scissors, or each kind of surgical instruments. Stainless steel have no biocompatibility. Of this case, it is unsuitable for implants. The material is extremely flexible and have a hardness of maximum 49 to 50 Rockwell. For the machining, it gives some challenges. Also here, the chips sticks to the tools, so lubrication is required. Also the advantage with the carbide tools, small radial cutting edge is possible, and we recommended that the tools must be coated. The articulation surface require really a perfect surface regarding the healing process. The other point will be the plastic. The polyethylene will be used for sliding products in area of knee, hips, and shoulders. The polyethylene simulates our cartilage material. It is biocompatible to the body and suitable for the permanent implants. It is high wear resistance but the surface of the implant are not perfect. Debris can cause bone destruction or some inflammation. Machine challenges here are extremely sharp tools are required, a dry cut or air is required, burrs difficult to avoid or to remove, and the chip evaluation is difficult, but we have here solutions. PEAK. This product will use in the area of spine for the cages, in the neurosurgery, or in the oral maxillofacial surgery. The excellent biocompatibility is perfect for the healing process. Especially in spine, the big advantages are the good shock absorbing and very stable structure of the material. Also, we have here some machining challenges. Extremely sharp tools are required. A dry cut or air is required. Burrs difficult to avoid or to remove. And the chip evaluation is difficult, but we have a solution. Now I would like to tell you a little bit about the common medical parts. We divide it here in 5 areas. Number 1 will be the dental. Here we are producing the implants and also the straight and curved abutments. Another point will be the orthopedics. Here we can produce the hip and the shoulder implants, different kind of bone planes, and a lot of products for the spine area. An important part will be the trauma. Here we have solutions for the screws and the blades. Another point will be the instruments, for example, for molds and for handles. And an important part will be the medical technology. We can offer here a lot of solutions for endoscopy, for the prosthetics, and also for different kind of medical devices. Index technology provides complete machining of orthopedics and osteosynthesis parts. Important are the high reliability and the durability. With our index and trope machines, you are total flexible. Depends of the part you can working from bar or via chucked workpieces. Now we are coming to the hip part. An artificial hip joint consists of 4 parts. It will be the hip cup, the hip ball, the hip cup inlay, and the hip stem. Depends of the patient's bone thickness and structures, the artificial hip joints are in different sizes available. It is modular assembly. It means each component can be replaced independently. For the 4 parts, it gives different kind of material solution. For example, if you have the cement version, we use here the cobalt chrome for the hip cups, or we have the cement-free version, then quite very often it will be used titanium. If you can see here, we have a wide range of different cases of hip bolts. Each manufacturer have his own design. So Mike, please give our customers a short impression about the possibility to produce the parts on our G200.
Mark, thank you very much. I'd like to take some time now to talk about the index machine solution, the G200. One of the key components for making medical parts and being profitable at it is to make sure that you have an accurate, consistent, reliable machining process. And to be profitable, you have to make sure that you're making those parts more accurately with less scrap rate than your competitors. How we are proposing and how we do hip cups and this type of machining is our G200 machine tool. This is a lathe with up to 3 tool carriers, all with Y-axis, and the upper tool carrier with an integrated B into the turret. This gives you powerful main and sub spindles with up to 7,200 RPMs, and it gives you the ability to do complex work pieces either on a bar or gantry loaded into the machine itself. It gives you full freedom because you have the ability to balance those parts from the main to the counter spindle because of the versatility of any of the turrets being able to work on either spindle at either time. We allow for quick changeovers and setups on this and a very compact footprint in taking up floor space. When you look at the machine itself, its spindle bore or bar diameter is 65 millimeters. Your spindle speeds are 6,000 RPM for your main and counter spindle with a 32 kilowatt max power and 170 newton meters of torque. Gives you a total turning length of about 660 millimeters and gives you a compact machine solution for that. When you look at the turrets themselves, the upper turret has the ability to articulate and be ran as a B-axis with a tool changer that gives you up to 5 tool change capability on the upper turret. And then the 2 lower turrets are, as I said, both Y-axis and the ability to work on either spindle, allowing for truly balanced machining of your parts. So what we'd like to do now is show you a video of the G200 in action. This is a hip cup machining process. It's made in cobalt chrome, roughly 50 millimeter length, 28 millimeter diameter bar. It's a 720-second part, and it's manufactured once again on our G200. You can see everything in action in the following video.
Now we are coming to the tulip head. An important part for the production will be the spine implants. With age, the vertebra and the disc between them become damaged. The doctors speak here about scoliosis, osteoporosis, and disc prolapse. A medical screw system uses rods and screws to stabilize and support the vertebra while maintaining mobility. In this area, we can offer different kind of parts. We have here on one side the titanium cages. On the other side, we have also the loops and the screws for the spine area. Important will be here that the products have a perfect surface because it will be drilled inside of the bone material and it must grow together. Also, the peak for the spine, the cages, must have a special solution because special bone material will be also involved that they grow together in the perfect way. So Mike, maybe you can tell us something about our new multi-spindle machine where we can produce the parts.
Thank you very much again, Mark. So one of the key components for being competitive in the medical industry today is to be faster and more accurate than your competition. Many different houses and manufacturing facilities around the United States use the same type of machines, traditional Swiss machines, whether it be Citizen, Star, or any of the other manufacturers that are out there. But you can have 6 traditional Swiss machines that all need an operator. They all need somebody there tending the machine 24 hours a day, 7 days a week. Or you can combine multiple machine operations into our MS series, our multi-spindle series, and kick a part out in usually a ratio of about 5 to 1. So what we're showing here is the MS-22 machine, which it incorporates a lot of our patented technology that we've developed over 108 years of production turning expertise. So when you look at the machine, you have up to 16 tool carriers with 1 or 2 axes and optional Y-axis in each of those. So when you're looking at this machine, don't think of it as a complicated multi-spindle. Think of it as 6 or 8 3-axis lathes. And what you're doing is you're dividing up the manufacturing process equally over those 6 individual lathes. The nice thing is it's combined in a very simple, easy to program format that is our design. So you have very high accuracy dynamic slide waves, non-wearing Z-axis due to quills and hydrostatic support I'll get into a little bit later. And then you have backworking where you can do complex parts and be able to hold extremely tight tolerances. You can use chucks or you can use bars. And then you have our integrated touch panel for easy operation and use from your operators. The work area itself, when you look at the machine, there's no external tool blocks, so you have fully functional chip fall. So you're not getting a lot of the stringers and the spinny, nasty chips getting wrapped around your tools because you're taking that horizontal approach. Gravity takes the chips down. It's an easier way to go from there. You have slides that you have 2 tools on each slide. So you have things that you can't normally do through our competitors' machines. You have 8 motorized spindles with stepless speed control, which means that they're fully integrated spindles. 0 to full RPM, back to full RPM the opposite direction in less than a second. Every spindle has a full C-axis. So literally anything you can think of that you want to be able to do, constant surface spinach, rapid acceleration, high torque, is completely programmable on these machine spindles. The Z-axis slide is an integrated spindle housing. I'll talk about that a little bit further on. And we're cooling the lubrication to direct cutting edges of each tool holder. So I can have up to 1,000 PSI at every single tool position in this machine, which allows me to extend my tool life, break my chips, get better production out of that. The key to a successful production of these parts is consistency. You can't have a thermally unstable machine tool. So Index has our patented core for all 8 of our spindles, which is a individually cooled system. It's a labyrinth style cooling system that allows you to cool multiple positions of every spindle and treat them independently. So a spindle that's doing a high acceleration can be next to a spindle that's doing a C-axis, accurate C-axis move and not transmit heat, therefore no Z-axis movement from one to the other. That gives you highest repeatability and extremely high accuracy. Also, the spindle drum transfers or rotates on a Hertz coupling system that allows us to maintain our position of all 8 spindles to within microns. So it allows for a very small compact area in a maintenance-free design. There's nothing that has to be done to control the cooling of those spindles. The tool slides themselves on the MS are manufactured and 100% designed by us. You have a maximum of 16 tool carriers, so 2 slides for each spindle. It's unique to us and our competition. Our competition has 1 slide per spindle. We have 2, so we can literally have twice the number of tools in any spindle. So that gives us a variety of use to be able to set up and engineer and change. Any driven or non-driven tool can be moved to any position at any time, and it's fully controlled within our spindle. The use of several tools allows us to be extremely versatile and reduce those cycle times down to minimum numbers. And you have full Z-axis for polygon turning and other extended uses. And don't forget, you can have Y-axis on many of these slides as well. Making sure we don't transmit vibration from one cutting tool position to the other is controlled by our hydrostatic bearing and our Z-axis quills. This allows for a wear-free, maintenance-free, backlash-free, high rigidity, optimal dampening position. So what we do is we transfer thousands of PSI of hydraulic fluid around that quill, which then acts as a hydrostatic bearing, which allows us to prevent or not transmit vibration from one cutting surface to the other. The other nice thing is this is a completely sealed system, so none of that hydraulic oil is going or mixing into your cutting oil. Okay, so let's take a minute to compare the costs and look at an ROI, return on investment, comparing the index multi-spindle to a traditional Swiss type machine. Your initial investment is a little over $2 million on the index versus $500,000 on the Swiss machine. Let's go ahead and set up a payment structure of 84 months on both of those and a monthly payment interest rate of 5.75. You'll see that your payments on the multi-spindle are roughly $30,000 a month compared to $7,200 a month on a Swiss machine. Your daily hour of operations is 20, and your cycle time is 60 seconds versus 348 seconds. What that means is our pieces per week is you're almost getting 6,000 pieces per week out of the MS-22-8 from Index versus 1,000 pieces per week on each Swiss machine. You take that over 50 weeks in a year, we're going to produce 290,000 parts versus 51,000 parts. Now, you take a look at your cost per piece, you're generating almost 34% additional profit running this on a multi-spindle as opposed to a traditional Swiss machine. Your cost per piece goes from $1.26 to $1.68. So you can see that the math works, the profitability is obvious, and the output is second to none. So what we would like to show in the next video is a tulip head being manufactured on an MS-22-8. This is going to be a 60-second cycle time, and it's roughly a 14-millimeter bar by 15 millimeters in length. Please enjoy the video.
Now I would like to speak with you about the bone screw. A bone screw is used whenever a fracture would not be healing properly without any additional fixation. Bone screws are used in orthopedics, maxillofacial surgery, and accident surgery. Screws are in different sizes, lengths, and shapes are available, depends of the fractures. Typical screw profiles are hexagon, slot, Torx, and square. There is a great variety of types of different bone screws. I would like to present you this variety. Number one will be the self-tapping screw. It means there is a pre-drilling required, but the screw cuts the thread by themselves. Standard screws, for example, they have nothing. It means the pre-drilling and the thread drilling must be done external. Cortical screw means there is no cutting with a thick core and a thin thread. And the spongiosa screws, it's different. So here is a thin core and a thick thread. So this depends of the bone material we treated. The other point is also cannulated screws. Quite very often happened that the doctor working here with a guided wire and the screws will be put it over. And also one important thing will be bicortical screws. So here it means the diameter will be very big, so 4.5 millimeters, but the head are extremely flat. Screws will be done in the different area. For example, the first one will be for the foot area, the second one will be, for example, for the hand, and the third screw is maybe for the spine area. On the right side, you see also the possibility, we have a special possibility to producing Torx. Mike, but you can say surely more about the machining of the bone screws with our machine.
Thank you again. So what we would like to talk about is our TNL series of Swiss machines. They are specialty designed for high mix, high volume manufacturing. What that means is when you have to do short runs or long runs, and you want to be able to change over from different part numbers in a very fast or succession. We have a very clearly structured work area with large axis travels and flexible machining. What does that mean? Traditionally, in a Swiss machine, you have what are known as slides. Those slides have gang tooling on those, and it's very difficult for your operator to set up those gang tools without poking, scraping, and sometimes even cutting themselves. With us, we have turrets. Traditional turret manufacturing, which means that you have the rotational of that tool, allows us to get a lot more tools in a much smaller area, and it allows us to have extreme flexibility in setup and changeover. These machines are designed to be able to have 2, 3, even 4 tools in the cut at all times, which greatly reduces your cycle times. We have a barothermal stable machine. You'll hear that many times as I'm going through the machine structures from Index. That's a big component of how we're able to hold the accuracies and consistencies in our part manufacturing. Turret indexing is an actual NC rotary axis. So now you can have your standard tool positions, but also add on many, many more, up to 52 tools in a very compact Swiss machine. You can have a robot for unloading or loading of this machine, and you have a very high acceleration, deceleration with our control and drive modules. You can see here the kinematics of the TNL 20-9, which is the first machine that we're talking about, and or a 29B. So traditionally, you would have gang tool position, and on here you actually have turrets, an upper and lower turret to allow for extreme versatility. And in the second version, you would have the ability to have a rotational turret with an integrated B-axis. The turret design is 8 stations per tool carrier. 3 tools per station is allowed, which means that we can have up to 24 tools per turret, with a chip-to-chip time of less than 0.3 seconds. You can have driven tools at every station. and very large tools as well, up to 45 millimeter tools for high rigidity, stability, dampening tool life, all of those things. You can have from 1,000 psi all the way up to 2,000 psi on up to 4 different stations. Once again, allowing for better chip flow, better chip breakage, more consistency, getting better coolant to your tool positions. And when we're dealing with highly difficult cobalt, chrome, titaniums, Inconels, Hastelloys, that allows you for longer tool life across that range. And you can have multiple tool holders in each tool station. This is an example of the advantage of having a turret as opposed to a gang station. If I was to put the same number of tools on this, as opposed to doing a rotational axis that I have in a turret, I would have to have up to 1,225 millimeters of y-axis travel versus a single turret. So now you can see here that I can get much more tools in the machine to have redundant tools, to have more complex parts, to be able to have more versatility in changeover, setup, and execution. We're going to show a bone screw being manufactured now on the machine itself. This is a 10 millimeter bar diameter by 60 millimeters in length. It's 207 seconds, and this is being manufactured on a T&L 29B. So this is the interactive B axis integrated into it.
Now I would like to give you some information about bone nails. Intramedullary nails, like bone nails, are driven into the marrow for long bones to treat fractures from within the bone. This usually takes place in splitter fractures or when bone plate stabilization is not possible. The bone nail provides strength and stability in the longitude axis, while rotation stability is achieved by screwing locking pins through the bone into the nail. This ensures stable and rapid healing for the fracture within 6 to 9 months. As you can see here, we have a wide range of different kinds of bone nails. Depends on the manufacturer, we have here special pockets or locking holes for the screws to fix the bone nail into the bone. Mike, what can you say about the T&L 32?
Okay, so the T&L 32 is a larger brother of the same style of machine that we talked about, the T&L 20-9. So it allows for simultaneous machining with up to 3 tools. It's easy and quick changeover utilizing the same style of turret. It also has a B-axis upper turret available on that. clearly structured work area with large access travels, allowing operators to be able to get in there, change tools, change over between jobs, and be extremely flexible. And once again, as we talked about, it's a very thermal symmetric design, allowing for almost zero thermal growth through the course of manufacturing throughout the day. You can see here the kinematics of the TNL32. You once again have the upper and lower turrets. You have a traditional sliding headstock style of machine, and we also can convert that to a fixed headstock style of machine if your parts require it. So you can go from a fixed to a sliding headstock with a very simple conversion and maintaining 3 tools in the cut throughout that. 10 stations per turret, 3 tools per station, 30 tools in each of the turrets, so 60 tools between the upper and lower turret. You have that same high speed rotation of that turret, allowing for 0.3 seconds chip to chip, and driven tools at every station. Coolant supplies, as we talked about before, are still available, and extremely large tool through the use of the multi-tool holders. So you have very efficient high cutting performance. It can be equipped with a front working attachment, which would allow you to get up to 4 tools in the cut on specific parts. You have Y-axis function on all 3 of those stations, so the upper turret, lower turret, and the front working attachment. You can have 4 additional stationary tools plus 4 additional live tools in that, and high pressure coolant throughout that. And when necessary, you can utilize this for tailstock functioning for outbound support of long parts. When we talk about the TNL32B style machine, with a backworking attachment, you can have up to 8 tool stations. Unique drive schemes offer high speeds or high torque. You can set that up for the type of material that you're running. And then you have an integrated workpiece discharge. You can do that by gripper or by running it out the subspindle. When you're talking about bone nails, you're going to go through one spindle, out the other. And an internal coolant supply allowing for high pressure coolant to any tool station at any time. So we're going to show you the manufacturing process on a bone nail that's out of 9mm bar and 220 millimeters of length. It's 543 seconds, and this is manufactured on our TNL32. So thank you very much. I want to go over a quick summary of the medical parts and the solutions from Index. As you can see from what we showed here today, this was a small taste of the types of products you can use, manufacture, and integrate through the Index Traub portfolio, covering dental, orthopedics, trauma, instruments, medical technology. We would love to have the opportunity to get to know you and your parts better, get you in touch with your local distributor and regional manager, and make a more customized presentation and cycle time analysis of your parts and your needs as a customer. We're going to follow up now with a complete video of many different types of medical parts integrated into a quick summary video as well.
Okay, thank you, Mike and Mark, for those overviews of the products. Very well done with those. For all of our attendees, it looks like we had one question come in during those. If you have any other questions that you would like to enter in the question box, please go ahead and do that now. And I am going to turn it over to Mike briefly to talk about some of the ways that Index is here to help you.
So what we want to do is we want to help your company prepare for the recovery. We know over the last year, all segments of the U.S. economy were hit by the COVID response, and we want to make sure that Index is here to help. To help optimize with your existing applications, how can you take work you're already making and become more profitable? Through time and cost studies, and even acceptance runoffs, we can set up and run and do these for you. Preventative maintenance for your existing Index Traub machines, and then additional operator training, offline training, and even in-person training. And finally, through turnkey development with your specific criteria. If we need to show you exactly how you can make a part, to help justify a machine purchase, we're willing to help you in those needs. So during the pandemic, Index has been dedicated to growth. We have been adding employees throughout the entire time, as opposed to traditionally eliminating positions. So I look forward to hearing from you through our local sales channels, and everybody have a good day. And I think we'll go to question and answer now.
Okay, so the first question we had come in here is asking, is it possible to justify an MS machine in a low volume, high mix business with estimated annual quantities of less than 5,000? And then second part, how about medium volume, medium mix with estimated annual units of 15,000 to 25,000?
I can take that one. Absolutely. We have customers that are running a couple hundred parts at a time and transitioning over to another workpiece. We have companies that have changed the way that they're looking at parts. And now the question is, what can't we put on the multi-spindle, or what are our holdbacks from that? And the reason being is, in the past, when people would think of rotary transfer machines, multi-spindles, those kind of things, they were always looking for what I like to call the magic bullet part. If I got this $1 million contract, I can justify this machine. Where all of our growth has been over the last 4 years has been taking customers that have same material, bar, style, parts, and running those through a machine on much lower quantities with a very high mix and changeover. So we are definitely, when we talk about here to help, able to not only do a turnkey on one specific part for you, but then show you how to lay out that machine so you minimize changeover, and then help you with the programming of that, so you can literally change from program to program, part to part, with minimum tools or bar and collet change, those kind of aspects. So it's definitely a shift in our way of doing machine tool sales. Is it's no longer high volume parts, it's high volume, high mix parts is where the success of our customers is coming from in multi-spindle purchases. To the point where I tell our sales teams, don't even go talk to customers that are current cam shops, because they won't get it. You have to go out and talk to the people that are Swiss shops and show them a way that they can make their parts very fast and much more profitable.
Very good. So our next question regarding the G200, what is the max speed of the Y-axis spindle?
I'm assuming you mean the B-axis upper turret, or do you mean the driven tool holders? So you can have 7,500 RPM, I believe, on the B-axis upper turret, and we have speeders and fluid-driven spindles that can go into a standard turret station that can go up to 50,000 RPMs.
Okay. The next question we had, it said there was mention that for titanium, you used coated tools for roughing and uncoated for finishing. What is the disadvantage of using a coated tool for finishing operations?
Mark, I'm going to leave that one to you. That was your part of the presentation.
Yes, thank you very much. It's difficult to say. It's only a suggestion what we get at that the people say if we are using this kind of tools, then this kind of instrument, they recommended it should be coated.
And then next we had, what is the warm-up cycle for the MS-22-8?
Because it is thermally stable, we're chilling all of the spindles and everything right from the start. Within a couple minutes of warm-up, you're ready to go. So you don't have to have a half-hour warm-up cycle or any of those things. Literally, the first part you make when you start in the morning is the same accuracy and consistency as the last part of the day. That's why we have so many ways of thermally controlling the machine. We don't want it to heat up and grow. We want to maintain that consistency.
Okay, so it looks like those were all of the questions that we received today. Obviously, anyone on the line, if you think of additional questions, please don't hesitate to reach out directly and we will get back to you on those. We want to thank you all for taking time out of your schedules to join us today. And it looks like we had one more question just come in from my CFO. Are there T&L machines available for year-end delivery?
Yes, there is. We have T&L machines in stock, and we have T&L machines on order that will be arriving before the end of the year.
Okay, very good. All right, well, if anyone thinks, like I said, if anyone thinks of any additional questions after the webinar, please don't hesitate to reach out. Thank you all for joining us, and have a great rest of your week.
Thank you.
From my side also, thank you very much.